Ask a 10-year-old what fire is and they'll tell you. It's hot, it's bright, it burns. Ask a physicist and they pause. The pause is the first piece of evidence. It tells you the case isn't closed. Fire has been part of human life for at least 1 million years. We have drawn it, cooked with it, worshipped it, studied it, and we still can't tell you with certainty which state of matter it is. Not solid, not liquid, not gas, though it contains hot gas. Not plasma, though at temperatures above approximately 3000 Kelvin, flames begin to ionize and produce regions of weak plasma. A candle flame sits in none of these categories cleanly. The most precise scientific definition of fire is a self-sustaining exothermic chain reaction. This is the unsolved case. The file is still open, and the primary object under investigation is the shape everyone takes for granted, the teardrop of a candle flame. It's an image so familiar it feels like a fact, but it's not. It's a mask. In plain language, fire is a process, not a thing. An event, combustion, hydrocarbons plus oxygen, rearranging themselves into carbon dioxide, water vapor, and energy. Process. That definition is almost a semantic escape. The physicist isn't answering what fire is. They're removing it from the classification system entirely. The evidence refuses to fit the boxes. So they set the boxes aside. That doesn't close the case. It opens it further. Then there's the color, the yellow glow that every human associates with a flame. Ask yourself where it comes from. The common assumption. It's the burning gas itself, hot and bright. The evidence says otherwise. Look at the base of a candle flame. It's blue. That blue region is the actual combustion, gas phase oxidation, a chemical reaction efficient enough to produce almost new soot. The blue is the fire burning clean. Now look at the yellow tongue above it. That yellow doesn't come from hot gas. It comes from solid particles, tiny soot particles, carbon nanoparticles formed by incomplete combustion. They are heated to incandescence, roughly 1400 Kelvin, and they glow exactly the way a metal rod glows orange when you hold it in a furnace. So when you watch a yellow campfire, you are mostly watching soot glow, solid carbon radiating light. The real fire, the gas phase burn, is the thin blue ghost beneath it. The visible flame is a solid masquerading as a gas. The color is physical evidence misread for centuries. The shape is stranger still. On Earth, every fire you've ever seen has a teardrop body. Hot gases rise. Cooler air rushes in from below. That convective flow stretches the reaction zone upward, creating the taper. The flicker is the flow being turbulent. The teardrop is a map of gravity, not a property of combustion. Remove gravity and fire loses its face. On the International Space Station in microgravity, flames become spheres. No teardrop, no flicker. A perfect, calm, hovering orb of blue light. The same chemistry without the buoyancy takes a shape no human ancestor could have predicted. The investigation turned up this evidence only in the last few decades. Combustion experiments in orbit, the flame extinguishment experiment, the burning and suppression of solids tests, recorded spherical flames that baffled researchers expecting Earth-side behavior. The shape we associate with fire is a fabrication of planetary conditions. The teardrop is not fire's identity. It's fire under the influence of one specific force. Back to the classification problem. The plasma debate. Some people insist that fire is plasma. It's an understandable assumption. Flames conduct electricity weakly. They respond to magnetic fields. That suggests ionization. But here the evidence demands precision. A typical candle flame burns at about 1400 Kelvin. A campfire reaches maybe 1800. A Bunsen burner can push 2200 ionization, the stripping of electrons from atoms to form a true plasma. does not begin appreciably until the temperature crosses approximately 3000 Kelvin. At that point, a flame starts to contain regions of weak plasma, where a fraction of a percent of the atoms are ionized. Above that threshold, the gas becomes more conductive, more responsive to electromagnetic fields. But even there, the ionization fraction is low. It's not a pure plasma, it's a mixed state. Some experts in plasma physics accept this weak ionization as plasma, others reject it, reserving the term for fully ionized states like the sun's corona. The scientific community has no unanimous verdict. Fire resists a clean state label even at extreme temperatures. The case file remains contested. Now the evidence takes a turn no one expected. The same process that defies categorization may be the reason our brains are large enough to care about the categorization at all. Hominids first controlled fire at least 1 million years ago. The archaeological record at sites like Wonderwork Cave in South Africa and Gesher Benat Yaakov in Israel preserves burned bone and ash layers that push the date deep into our ancestry. Once fire was tamed, it allowed something unprecedented: cooking. Heat breaks down tough proteins and carbohydrates. It externalizes part of digestion. A cooked meal delivers more usable calories to the body than a raw one of the same weight. This had a biological consequence. The gut, the expensive organ responsible for processing raw food, could shrink. The metabolic budget that had been allocated to digestion could be reassigned. And according to the cooking hypothesis, championed by biological anthropologist Richard Wrangham, that surplus energy went to the brain. The human brain is disproportionately large for our body size. It consumes about 20% of our resting metabolic rate. The shift from raw forage to cooked food provided the caloric headroom for that expansion. Fire, then, didn't just keep us warm, it rewired the energetic economy of our species. Every line of inquiry, every classification debate about flame chemistry is a conversation made possible by the very phenomenon being interrogated. The process built the mind that analyzes the process. After a million years, we return to the teardrop. The familiar candle flame is no longer a simple image. It is a tapestry. The blue base, gas phase combustion, the chemical event itself, the yellow body glowing solid soot, a cloud of carbon nanoparticles radiating because they're hot, the shape not a birthright, but a gravity-dependent flow pattern, a version of fire specific to this planet's pull, and threaded through all of it the faint partial ionization at the hottest edges, a whispered plasma that refuses to give a clear state. Fire is a self-sustaining exothermic chain reaction, a process. That is the reluctant verdict, but the word process isn't entirely satisfying. It feels like a classification dodge, a way of saying the phenomenon doesn't fit our neat boxes, so we call it an event and move on. Perhaps the failure isn't fires. Perhaps the failure is in the classification system itself, invented by a brain that was itself fueled by this unclassifiable thing. The teardrop flickers on the wick. Solid gas, weak plasma, all held in a shape sculpted by buoyancy. It is a dynamic assembly of matter across multiple states, none of which claim it alone. The case is closed, but it exposes the system's flaws. The 10-year-old says, "It's hot, it's bright, it burns." The physicist pauses. The evidence tells us why. Fire is not a state of matter. It fueled the evolution of our large brains, and it's still burning,